Okay, ladies and gentlemen, boys and girls, this is 6.7. It's the last lesson in Unit 6. It's also the most difficult lesson in Unit 6, okay? So at this point, you know how to generate equations for lines, okay? You can get any information from a line. As long as you have enough information, you can generate an equation for that line. You also know the difference between standard form of an equation and slope-intercept form of an equation, and you're comfortable working with both of those things, okay? You can rearrange them if needed. You've got all those skills. Today we're talking about something called linear systems. Now, in order for it to be a linear system, there has to be two or more lines. Okay, so we're not just talking about one line and one equation. Now we're going to have two equations. We're going to say, okay, how do these lines interact with each other? Now just think about two lines. What are the options for how two lines can relate to each other?
Parallel.
They could be parallel, which means that they would have
The
the same slope. Good. What else could happen? They could be perpendicular, which means the negative reciprocal slope. Good. Third option,
You said they were
Neither.
they might just intersect but not at a right angle. Okay, so they're either parallel, right angle, or anything in between those two options would mean that they are just going to intersect. Now, there's a fourth option, kind of. They could be the same line, in which case they would be coincident, right? We've heard that word before. Coincident means they're actually just two equations that look different, but they're the same line, okay? We've seen how that works out a little bit before. So let's take some notes at the top. The notes are starting with the word linear system. Linear system, a set of two or more linear equations that are considered at the same time. So if you have two lines that you're thinking about at the same time, you have a system of linear equations. A good example of that would be if you had a cell phone plan and there was option A and option B. And option A was that it's $40 a month, unlimited everything. Okay, it's always going to be $40 a month. Doesn't matter how much you use it, $40. Okay, option B is it's going to cost $20 at the start, and then 5 cents a minute and 5 cents a text. Okay, that graph is going to look like that. So when you're considering both those options at the same time, you're considering the system of linear equations, or a linear system. Now what we're going to be doing is we're going to be finding out where they intersect, or you might want to know under what circumstances is option A better than option B, and under what circumstances is option B better than option A. Okay? So for you, option A would be cheaper if you use more minutes than whatever number is here on the x-axis. Okay? Option B is cheaper if you don't use your phone that much. Make sense? So that's what we're doing with linear systems. Second thing there is the point of intersection. The point of intersection, this is the point where the lines cross. Okay, so if you draw a little bit of a diagram, you have some space there. Right there is the POI. Now, one really important thing to know, and it's going to take a while for you to realize this, remember this, apply this, but remember any point on the graph, no matter where it is, can be represented by coordinates, x, y. Now, we've already learned that if these coordinates are on the line, they satisfy the equation of that line. So knowing that, what's going to be true about this point, x, y? It's going to satisfy this equation and this equation. Is there any other point in the whole world that will satisfy both equations?
No.
No. Okay, you could pick this point down here, but it'll only satisfy this line's equation. Or you could pick a point over here, it'll only satisfy this line's equation. This point will satisfy both equations. It's the only set of coordinates in the whole world that will ever do that, up to 1,000,000, infinity, etc., and beyond. Okay? Very important information. Here we go. So let's talk about how these lines could interact. Okay, you have a little chart there. You said that one of the options is that they are parallel. So in your first box there, you've got parallel. And just go ahead and draw two parallel lines. Use a ruler. Go ahead and draw a set of parallel lines on the grid that I've given you. Okay, two parallel lines. Doesn't matter what yours look like as long as they're parallel. Go for it. And what do we need to know about these? Well, in the bottom box there, these lines will never cross. Never, ever, ever. They'll never touch. They'll never cross. Okay? Now, remember we talked about point of intersection? Will two parallel lines have a point of intersection? No. So is there a single point that will satisfy both equations? No. There is no point, and then give yourself a little xy, that will satisfy both equations. Last thing, here's a new vocabulary for you. Not really new, we've used it before. There is no solution. Remember, if you can find the x and the y that satisfy an equation, that's also called the solution to the equation. We learned about that in an earlier unit. In this case, you will not be able to find a solution. There isn't one. Okay? Yes?
But can't you just pick one point that satisfies one line since they're both the same line?
The goal when dealing with linear systems and solving linear system is to find the point of intersection. So basically you'll be given two lines, and they might not be in the same form. They might look really different. You'll just be given two equations, and you'll have to find the point of intersection. Now, if you cannot find the point of intersection, if there is no solution, then you know those lines are parallel. Even if you don't know the slope of each of those lines, you can tell that they're parallel if there's no solution. If you find a solution, you know they're not parallel. You know they're one of these two options. They are, I'm going to use intersecting. And then maybe in brackets underneath that, you can just write non-parallel. Now, we don't separate intersecting at a right angle and intersecting at some different angle. It doesn't matter to us in this scenario if they're perpendicular or not, because we're looking for their point of intersection. Okay? So whether it's a right angle or not, we don't care. As long as they intersect, that's what we're looking for, the solution. Okay? So go ahead and just draw a set of lines that intersect. Do not draw lines that intersect at a right angle. Okay? I don't want that to be confusing right now. And ideally, you would make them not intersect where I did. I made them intersect right on an axis. I don't want that to confuse you. It doesn't matter, really. These are still intersecting lines, so it works. Okay, notes about this. These lines intersect at one point. Point XY. We have to find out what X and Y are, but they intersect at one point. Okay? This is the only point that what?
The whole world. that it satisfies.
That satisfies both equations. The only point that satisfies both equations. If you have some space, there is one solution.
Oh, so the solution is the point.
Correct. If you can find the xy where they meet, the point of intersection, then you have solved the linear system.
Gotcha.
Okay? And the last set of lines, I'm going to write it two ways. I'm going to write coincident, and under there, you've got two identical lines. Okay? If they're coincident, they are two identical lines. Now, I only gave you one graph there. Could have given you two, but basically what you're going to want to do is you're going to want to take two colors, if you have them, and try to draw the exact same thing as me. Okay, I'm going to go through a y-axis, y-intercept of 2, and an x-intercept of 3. Okay, I'm going to draw a straight line through that in green, and I'm going to draw a straight line through that in blue.
For people that only have one chart, can we just label the lines A and B? Or like,
Sure. They're the exact same line though.
Why
So-
do you use two colors?
Because it's actually two lines, they're just identical lines. So I'm use two colors because I'm going to label each of those lines. The green line is called 2x plus 3y equals 6. And the blue line is 4x plus 6y equals 12. That's two equations. They look different, but in fact they are the exact same line.
You just doubled it.
I just multiplied all the terms by 2. Could I have divided all the terms by 2?
Yes.
Yep. Could I have multiplied all the terms by 4 over 3?
Yes.
Yep. Okay, you'll get the same line over. Could I have just converted into y equals mx plus b?
Yes.
Yeah. As long as I do it properly using my algebra skills, I can rearrange it and it will still be the same line. Okay, so here's a few notes. Although the equations look different,
Didn't we have to draw another line?
we did, we drew two lines. They describe
We wrote each other.
You draw on top of each other.
the same line. It's actually only one line, right? They're two equations that describe the same line. Now, what's interesting about the points that are on the line?
They intersect.
They're parallel.
No, they're the y-intercept.
All the
Yeah,
points satisfy
All
the equation.
good. All points on one line satisfy the equation of the other line. All points on one line satisfy the equation of the other line. And the last note, there are how many solutions?
One.
Infinite.
Infinite solutions. What does that mean? Well, that means this point is on both lines, and this point is on both lines, and this point satisfies both equations, and this point is on both lines, and this point satisfies both equations, and this point, and this point, and this point, this point, and this point, and this point, and this point, and every point in between, all the way to positive infinity, all the way to negative infinity. Okay?
Sure.
Graph the following lines on the same grid, identify the coordinates of the point of intersection, and then verify that your solution satisfies both equations. So here we go. I should have drawn you guys a grid. Pardon? Oh. I should have drawn you guys, no. I should have drawn you guys a grid, but go ahead and draw a grid about halfway down the page. The bottom half of the page you can use to make your grid look like this. And the two lines that we need to graph are y equals 1/2 x minus 3. So we'll do that one first. Y equals 1/2 x minus 3. What does this equation tell us? It's going to go through,
-3.
the y-intercept is -3, so we've got a point there. And it's got a rise over run of 1/2. Okay, so as it goes up 1, it's going to go over 2. Up 1 over 2, up 1 over 2. And by the time you've gone up 3, how many should you have gone over?
6.
Should have gone over 6. Okay, so now you have 2 points. And if you have 2 points, you can draw a line.
That is right.
And our other line is x plus y equals -6. X plus y equals -6. Now, do I know what that line looks like just by looking at it?
The y-intercept is -6.
No.
I do not know what it looks like just by looking at it. I could convert into y equals mx plus b, or I could find the x and y intercept, which will give me 2 points, and I can draw a line. I'm going to do that. So to find the x-intercept, I set y to 0, in which case x equals -6. So that's the x-intercept. 1, 2, 3, 4, 5, 6. -6. There it is. And I can find the y-intercept by setting 0 equals x. X equals 0, which gives me y equals -6. Right down there. And if I have 2 points,
You can draw it.
I can draw a line. Now, because you have drawn your graph absolutely perfectly,
Actually, I messed up.
you can see that the point of intersection appears to be at -2, -4. So we'll label that point.
Who's to be it actually is.
Okay? Okay, so the point of intersection is at -2, -4. Another way to say that is that this is the solution to the equation, to the system of linear equations. So we have the 2 lines intersect at -2, -4. This is the solution to this linear system. So you get a question that says, what's the solution to the linear system? Well, you know that means point of intersection. There you go. -2, -4 is the answer to the question, or the solution to the linear system. Now, we need to verify that that solution, -2, -4, actually does satisfy both equations. If we find that it does not satisfy both equations, then it's not actually a solution, and we made a mistake. Okay? So I'm going to take this blue line here, which was y equals 1/2 x minus 3, and we're going to see if the points -2, -4 satisfy the equation. What does that actually mean? I'm going to put them in, and then what? If it's still true, I know it satisfies the equation. So here we go. Y is -4.
Doesn't it have to equal 0?
X is -2. Now, if it turns out that after I do math on this, this is still true, then then the point -2, -4 does satisfy the blue equation. It does satisfy this. Okay, so this is B that we're working on now. Verify. Okay, let's see what happens. -4 on the left. 1/2 times -2 is -1. Minus 3. -4 equals -4. So we'd say left side equals right side. So therefore it does satisfy this equation. And we'll skate over to our red line, which was x plus y equals -6. We'll sub in our points there, making sure we sub them in the correct spot. We have -2 plus -4. -2 plus -4 is the same as -2 minus 4, which is -6. On the right, so we have left side equals right side here. Okay? And then we can say, therefore, the point -2, -4 satisfies both equations. Therefore, it is the correct solution to the linear system. We're going to look at one quick on Desmos. I'll graph 2 lines and you can see the point of intersection that way. And then you've got your key concepts at the bottom. Okay, the key concepts: a linear system is 2 or more linear equations considered together. The solution of a linear system of 2 equations is the point at which their graphs intersect. In order to make sure that you did it right, the coordinates of a solution must satisfy both equations. So your practice problems are on the back of that page, page 26. And I'll just show you on Desmos quick as well.